I'm Anil Kumar sharing with you an excellent test paper, very balanced, on similar triangles and trigonometry ratios. The student Rayad has done excellent in this paper. So we already discussed first few questions. Let's go through them once again. The first one is calculate the following angles. We are given trigonometric ratios, primary trigonometric ratios, sine theta, cosine A, tan x. And then you have to find the angle, which you can find by calculating their inverse, right? Sine inverse of 4 over 5 will give you the angle. Likewise, you can calculate the others. Question number 2 is to solve for the missing side lengths. So we know sine 32 is x over 10, for example. You need to find x. It's like solving ratios, right? And here we have cosine 15 equals to 19 over 5. And then we have question number 3, which is based on similar triangles. So two triangles where the scale factor is 24 divided by 4 or 18 divided by 3 or 30 divided by 5 all give you 6, which is the scale factor. So whenever you talk about similar triangles, it is always the scale factor we look into. So we're done with similar triangles. Now we have a fill in the blanks which says complete the following statement. All congruent triangles are similar, but not every triangle that is similar is congruent. It is very important to remember that, and it's good to see this statement in a test paper. Now, there are question number 5 and 6 here. I will discuss question number 5 in details. Question number 6 is, we are given two similar triangles, right? Right angles and these two sides are equal. So from the property AA, these two triangles, ABC and ADE, are similar. Now since the base is in the ratio of 1:2, right? So the side AB is to AD should also be in the ratio of 1:2, and that gives us x centimeters as equals to 4 centimeters, right? So we get that answer, and now I will discuss with you how to solve these kinds of ratios, right? So whenever we are actually dealing with similar triangles and trigonometry, we will land up with situations which at times will be difficult to solve. In this test paper, we do have questions which have similar kind of ratios. Now let us see how to solve 1 over 3 equals to n plus 3 divided by 27, and the second one here is n over 3 equals to 2n minus 1 divided by 4. You can pause the video, solve, and then look into my suggestion. Well, in this particular case, since 27 is a product of 3, we can actually simplify it and write 27 over 3 equals to n plus 3, right? Multiplying both sides by 27. 27 divided by 3 is 9, so 9 equals to n plus 3. And now we can take away 3 from both sides. So 9 minus 3 is equal to n, or we can say n is equals to 6. So that is how we can solve the first ratio. In the second ratio, however, we have 3 and 4, which are not multiples of one another, right? So we can now cross multiply, or you can say multiply both sides by common denominator of 12. Either way, so what do we get? We get 4 times n, so 4 gets multiplied by n, and 3 times 2n minus 1. So at times you might do a mistake here. This number 3 I should have written here. I have done myself. 3 is being multiplied by 2n minus 1, both of them. Now apply the distributive property and expand the right side. So we get 3 times 2n as 6n, and 3 times minus 1 is minus 3. Now you can bring constants to one side and variables to the other. So we'll prefer to get 3 here. Since it is minus, we'll add 3 on both sides. Subtract 4n, we'll get 6n minus 4n. And that gives us 3 equals to 2n, or n equals to 3 over 2, right? Which you may write as 1.5. So that is how you can solve such ratios. It is interesting to see that the teacher has taken up a question which is based on ratios in a paper which is on similar triangles and trigonometry. I think it is an integral part and it should always be there, right? So I really appreciate it. I hope you also appreciate it. Go through the other test questions. That will definitely help you to get excellent marks, just as Rayat. Thank you and all the best.